This is a video giving you some help on the glassware and types of um, how we use glassware in chemistry. Even though you guys are doing most of your labs at home, the Sapling Lab for the Density Lab is going to go through some of the glassware that's used in a chemistry lab and how to read and use that glassware. So I wanted to give you guys a little bit of an intro for that and then how to use that for your density calculations. So we'll just kind of talk about some of the glassware. First one of the most common known pieces of glassware called a beaker. A simple glass, kind of looks like a glass jar. Some beakers will have marks on them indicating some volumes, but some won't. They aren't very accurate, so we don't usually pay too much attention to those. When we do need to pay attention to those markings telling us a volume, that's usually using a graduated cylinder, which is a long, skinny piece of glassware that usually has some sort of plastic or glass base. So this is a graduated cylinder. Whenever we have a glassware that is graduated, what that means is it's going to have a number of markings all the way up. The volume will be graduated all the way up the side of that glassware. We're actually going to talk about how to measure a volume with a graduated cylinder in a little bit. Another piece of common glassware, one that's depicted a lot, usually to represent chemistry, is this kind of volcano triangle shaped piece of glass, and this is called an Erlenmeyer flask. And just like the beaker, sometimes it'll have markings, sometimes not. They're not very accurate, so we usually don't look at them at all. When we need to use a flask that does have an accurate mark on it, we use what's called a volumetric flask. And anytime we talk about volumetric glassware, that's going to be a much more accurate piece of glassware. A volumetric flask is going to have one marking on it, one volume marking. So you would choose your volumetric flask for whatever volume you want. If it's 10 milliliters one, that will be the 10 milliliter mark. There won't be any marks in between. It'll just have that one mark. So this is called a volumetric flask. The other type of volumetric glassware, but volumetric pipette, is used a lot. We won't talk about that for this class though. We have a kind of a bumped up version of a graduated cylinder if we need a more accurate volume reading. Again, it's going to be a long skinny piece of glassware. It'll have what's called a stop cock, something that blocks the liquid from draining out the bottom, and this is called a burette. And again, this will have a bunch of markings on the side saying what your volume is. So for our density calculations, when we do or calculate density in labs, we use a graduated cylinder and a burette. So let's talk about the differences between these two to kind of look at how these are used. So these are glassware that are used to measure a volume. Let's look at a graduated cylinder. Versus a burette. So one thing about them, their general shape is the same. Okay, they're basically long and skinny. And that allows us to get a better definition between volumes. So they're both going to be long and skinny. A key thing about graduated cylinders versus burettes. So graduated cylinder, you're going to pour your liquid in. So we'll say you pour your liquid in, and to get it out, you then pour it out. Okay. So that's how a graduated cylinder is used, whereas a burette, you're going to pour your liquid in, and you're going to end up draining that liquid out the bottom. Now, the reason that I distinguish between these two is that's going to tell us how we read our volume markings. So on a graduated cylinder, because we're pouring in and then pouring out, our volume readings are going to read up. So let's say this is, say, 30, and that's a 40 milliliter marking. Whereas in a burette, because we're going to be draining that liquid level down, our readings, our lines, are going to go down. Okay, and the burette is actually a much more accurate piece of glassware, so it's not going to have a big step like between 30 and 40 milliliters. The biggest markings on a burette are going to go, say, between 40 and 41, so just a 1 milliliter difference between markings there. So we have some other markings in there. Usually the halfway point is a little bit bigger. So over here, our halfway mark would be the 40.5, whereas over here, this would be 35. So usually we work in tens. And when we fill these two pieces of glassware with some sort of liquid, water, any other solution, you'll notice, or you would notice, that the liquid takes on this kind of curvature. And this curvature is what's called a meniscus. And the meniscus is the curvature of a liquid basically in a container, and it has to do with some interaction that's happening between the liquid and the sides, the glass sides there. So we are going to use a graduated cylinder and a burette in order to determine a volume of a liquid. Okay, so to read a volume, what we want to do is we want to read the bottom of this meniscus, not the top of there. We want to read the bottom. And if we were doing this in a lab setting, you would want to get at eye level to the bottom of that meniscus. Move my camera down here. So to read a volume, we're going to use the bottom of the meniscus. Oops. There's a C there, meniscus. Let's just rewrite that. And we want to get to eye level. Then we, just like in one of the earlier lectures in chapter 1, measuring the length of that metal rod, we want to basically determine in between what markings is the bottom of our meniscus and then we want to estimate that last digit. So if we wanted to determine the volume of this line here, we know that this meniscus, the bottom of the meniscus, is between 30 and 40. So we know that the 10th digit will be 3 because it's not going to be larger than 4. Then we also know that that meniscus, well, I'm going to say that that meniscus is right on that hash mark there. Okay, right on that middle hash mark, which that middle hash mark represents 5. So we have 35. Okay. And when I'm estimating that it's right on that mark, I'm saying that it is not above it, it's not below it, so I'm estimating that tenths place is going to be a 0.0. Okay, I'm saying that it's right on that mark. If I wanted to say it's right above, then that would be 0.1. And since these are volumes, these are all in milliliters. And what's important for us to distinguish here is we have the 3 and the 5 for 35. These are the known values. Whereas the 0 in the tenths place, this is the unknown, the estimated value. Okay, and that's where our significant figures come in, because this is what's going to change depending on who's looking at this value, who's looking at determining this volume. Okay, with our burette over here on the right, we do the same procedure for determining our volume. Okay, I know it's between the 40 and the 41 mark, but remember that these numbers are opposite from these here. So we're between 40 and 41, so I know that my value is at a 40. These markings in between represent tenths, so I'm going to say it's between the 0.5 mark and the 0.6 mark. So we know that that's then 0.5. And I'm going to estimate that the bottom of this meniscus is a little shy of a third of the way between these. Okay, remember, this is what you see. This is how you see that measurement. So I'm going to say that that's about, just a little bit shy of a third. So I'm going to say that that is 0.52. Okay, and again, that's milliliters. So our known values are the 4, the 0, and the 5. And the 2 is our estimated value. So not only is our graduated cylinder and burette reverse of each other, they also have a different level of accuracy. Okay, a graduated cylinder is going to be accurate to the tenths. Okay, one number past the decimal. A burette is accurate to the hundredths. So let's talk now about how these two pieces of equipment are used to determine density, since density, one of the values of it is volume. Let's talk about how to do that in a lab setting, which is what you'll be looking at on the Sapling site. Kind of looking at density and labware. I say labware instead of glassware because I'm going to introduce some other things besides glassware. So when we look at density, we're going to separate how we determine density of a solid versus a liquid. So let's start with solid objects. We want to determine the density via what's called the volume displacement method. And when we do this volume displacement, we are going to use a graduated cylinder. So how we're going to do that, this volume displacement works on the concept that the volume of our solid object is going to be equal to the difference between our final volume and our initial volume. So what this looks like in kind of cartoons, we have our graduated cylinder, and we have some metal object. And what we want to do is get an initial, so graduated cylinder, we get an initial volume reading. And then what we want to do is we will put our solid object into that graduated cylinder. That object is going to occupy some space in that graduated cylinder, so it's going to displace some of our water. So there's our solid object in there. So the volume of our water or liquid is going to increase. So this first volume, this is going to be our initial volume. Second volume is going to be our final volume. And the difference between those will get us the volume of our solid object. Then we can determine our mass by using a balance. Balance is like a scale. Once you have that, then you take your density is going to be the mass of your solid object divided by the volume of your object. Now for our liquids, okay, so that was solid objects. To use our liquids, we're going to determine our density by determining the mass of a known volume of the liquid. We're going to do this by using a burette. So same concept, the volume of our liquid is still going to be the difference in the volume. So volume of our liquid will be the final volume minus the initial volume. We're going to have a slightly different setup for that. We'll have our burette. And remember, the liquid out of the burette flows outward, goes down rather than being poured out. So we want to pour that liquid into a container, in this case a beaker, doesn't really matter. Okay. And our beaker either is going to have some sort of mass here, okay, or sometimes we can what's called tare or zero out our balance. Okay, so this is our balance here. So if we have a known amount of liquid in there, we then drain some of that liquid into our beaker. So our volume will then decrease. That liquid will then be in our beaker. Then our density of that liquid is going to be the mass of the liquid divided by the volume. Now this mass of the liquid, sometimes, like I said, you can balance, you can zero out your balance so that initially you're reading a zero mass here. Then whatever mass is added from your liquid, that would be what you read off the balance. Sometimes you may not zero it out, so you may end up having to do another subtraction where you have the mass of the liquid going to equal your mass of your final minus the mass of the initial. Or a different way of looking at that, your mass of your liquid is going to be the mass of the beaker plus the liquid minus the mass of just the beaker by itself. Okay, that's another way of looking at it. So what you guys are going to do for the Sapling Density Lab is it's going to go through kind of identifying some different pieces of glassware. Then it will give you some practice reading a graduated cylinder and then working with determining the density of solid objects. Then you'll go into practicing taking the measurement of a volume in a burette and determining the density of a liquid.